Hi, we are EGR 305, Section 01, Group 5. The project we did for our final project is the Model Steam Locomotive 060t Decauville. I am Leo Francor.
I'm Aditi Karat.
I am Gabriel Morgan.
And I'm Andrew Valenti.
In this slide, I will be discussing subassembly 01110, which is the lower frame assembly. This assembly is one of the assemblies used to make up the final assembly, and it is made up of 9 different subassemblies. For each of these subassemblies, the workbenches that were used are part design, generative sheet metal, and the sketch tracer workbench. The sketch tracer workbench was used to create the frame on the left-hand side and on the right-hand side because the drawings did not provide enough dimensions to be able to accurately design and dimension each of those parts. And these parts are major components, as you can see. Most of the assemblies attach to those frames. Additionally, another challenge that was faced is that there is a large amount of parts used to make this assembly. Approximately 45 parts were designed and is what makes up this complete assembly. Also, some of the dimensions we found were incorrect for the drawings, and when we were assembled, the parts did fit together and just this assembly with minor issues. But when we put this assembly into the final assembly, we found that there were a lot of issues where a lot of parts were clashing and did not meet with each other like was in the original design. The materials used in this assembly are bronze, copper, steel, and brass. And in the next few slides, I will go through and talk about more of the subassemblies. This is subassembly 01101. It is one of the first subassemblies used to make assembly 01110, which is what I just discussed in the previous slide. For this subassembly, this is actually the right side frame assembly, and it contains subassembly 107 and 105. Similarly, this is subassembly 01102, which is the left side frame assembly. It is very similar to subassembly 101, but in this frame we have a slight curved hole, and also we have this additional part, which is part 0117. And now I will be discussing the smaller subassemblies that were used to make up the subassemblies mentioned in the previous slides. On the left we have subassembly 103, which is the front side frame, and on the right side we have assembly 104, which is the rear side frame. Both of these assemblies were mostly made out of steel and were easy to assemble. Similarly, we have assemblies 105 and 106, both made out of brass and both simple designs. Assembly 105 is the right-hand side valve gear main plate assembly, and assembly 106 is the left-hand side valve gear main plate assembly. Some subassemblies 107 and 108 are in this slide, and subassembly 107 is the right-hand side valve chamber, and 108 is the left-hand side valve chamber. These assemblies are mostly made out of brass, except for the steel parts that we have coming out of the front here. And also we have some bronze fittings in both of these subassemblies. These are both mirrored parts of each other and fit on the different frames that were mentioned in the first assembly. This is subassembly 01109. It is the boiler water injector pump. It is primarily made up of brass, and on the sides we have rubber water hoses. And this is the last subassembly that is used to make up the major subassembly, which is subassembly 01110.
This is subassembly number 2, which is mounted on subassembly number 1. As you can see, there were, for this assembly, there were a couple of parts which were connected individually, like the rods here, and the rods which will go in this box, and these rods as well. So it was a little bit challenging to put this assembly together in that sense. Most of the parts in this assembly were made in part design and generative sheet metal design. One of the main assemblies were the wheels. This is the front wheel. These are the rear wheel assemblies. They're connected to, the assembly actually connects both the sides of wheels together. In the next slide, here's the top view. In this view, you can see that there's the piston assembly over here, and there are a couple more parts that go in the middle, and this view shows clearly how all the parts are connected together. This is subassembly 101 and 102 of my subassemblies. Here is the front wheel, and here is the rear wheel assembly. Both of the assemblies are kind of similar, except the spoke for rear wheel, one of the spokes for rear wheel is bigger. For the front wheel, they're all symmetrical except over here where the cap screw goes. This is the rod axle. All the parts for these two assemblies were made of steel. For the rear wheel, two additional parts are added to the assembly. This is kind of a piston-shaped roller, and then this is eccentric. Eccentric connects all the wheels in the assembly. This connects the middle portion of SA01 to my assemblies to keep it connected to the base. One of the difficulties for this assembly was eccentric, since the dimensions of eccentric were not given completely, so there were dimensions that I had to assume, or I had to change after putting it all together. This is piston assembly. The main parts for this assembly are crosshead, piston rod, and piston. The crosshead is made of brass, connects to the rear wheel eccentric. The rod and piston are connected to subassembly 01, and they're made of steel. Both the assemblies, the assembly connects it to the base assembly, and one of the challenging part for this assembly was, again, to get the dimensions for this part, crosshead, because of dimensioning issues that we had when making it and when putting it in assembly. These are assemblies 104 of subassembly 2 and assembly 105 of subassembly 2. They're valve assembly. They connect to rear wheel and valve chamber from, again, subassembly 1. These parts are made of brass and rest is made of steel. The main three parts were brass, were valve rod, and valve nut. Valve nut and valve rod are made of steel, and one of the complicated parts was to get the valve nut dimensions right, because the dimensions that were given to us did not match the rest of the dimensions of this assembly. And the difference between these two assemblies is that one connects on the left side of the train, one connects on the right side of the train, so they are the connections are mirror image of each other. This is subassembly 106 of subassembly 2. It is gear shaft subassembly. It connects the rear wheel assembly to from either the sides to the main base assembly using these cranks. Main parts of this assembly are gear main shaft, which is this part, and reversing gear main shaft cranks. Both the parts in this assembly are made of steel. These were really simple assemblies connecting on the both sides.
The first subassembly that I was responsible was subassembly 03-101. This was the boiler firebox and tubes that come out of the firebox. This subassembly is made out of primarily bronze and copper with a little bit of brass. The firebox is made out of bronze, where the tubing is made out of copper, and the small fire hole oval ring is the piece that is made out of brass. Most of these parts were made with the part design, but the boiler crown stay up on top of the firebox was made with sheet metal. The second subassembly on the right is subassembly 03-102. That is the boiler water level indicator and also the drain release tap system. This subassembly is made primarily out of brass with a couple copper tubing pieces and some glass and rubber for the indicator or portion of the subassembly. Next on the left we have subassembly 03-103, which is the boiler safety release valve. This valve is designed to release excess pressure from the boiler in the event that it reaches unsafe levels. The base of the safety valve that connects to the main boiler body is made out of bronze, where the rest of the subassembly, aside from the springs, is made out of brass, which the springs are made out of steel. Most of the parts in this subassembly were made with part design, but the springs were made in generative shape design. On the right we have subassembly 03-104. This subassembly is the boiler control hub, where the conductor can interact with various control points to change the operation of the boiler. We have subassembly 102 in here as well, the water level indicator, along with a pressure gauge dial. Above that is the boiler steam valve dial to adjust the steam output. And then down here is the fire hole door, and on the side here we have two different water drain. The water drain tubes are made out of copper, along with the tubes leading to the pressure gauge and the water level indicator. The fire hole door and most of the joints of the subassembly are made out of brass, and the main body is made out of bronze. Most of the connecting points were made with part design, whereas all the tubes were made with generative shape design. And finally, here we have the final full subassembly of the boiler, containing the firebox, which is on the interior, or the safety valve here, along with the control hub and the main body tube for the boiler. Along with these components, there were a couple other, one of which was the boiler steam delivery tube here. This was made with generative shape design. It snakes in here and then comes across the middle. Another part that was made with a different workbench was the grate tube, which is underneath inside here. It was made with generative sheet metal design. The creation of this assembly went rather smoothly, other than a couple little slight mismatches, mainly between the boiler steam delivery tube and the boiler body, but that was rectified by adjusting one of the angles at which the tube ran. Another main thing was all these rivets, which would have been very tedious to do individually, but The reuse pattern allowed all these rivets to be placed in and copied after one was constrained to the original pattern on the boiler, and just the pattern repeated and all the constraints repeated as well. So each set only needed to be done once and then the pattern repeated.
The first subassembly that I took care of was subassembly SA04-105. This subassembly that you can see here is where the conductor would stand on the train. It's kind of the control room. A lot of this is made of generative sheet metal design parts, because a lot of these parts are just sheet metal bent in all sorts of ways. One big issue with this subassembly was the way the holes are lined up. The holes didn't really align when I made the parts, so I had to kind of make my own references and align the holes in a way that would make them line up with each other instead of just be at seemingly random junctures. If you look in the top right corner, you'll see the 3D model of this subassembly. As you can see, there is a lot of sheet metal involved, and all the pieces are rather thin. If you keep looking, you'll see around the back how there's a lot of holes everywhere, and those holes connect to the rest of the steam engine and to itself. As I mentioned earlier, those holes are often misaligned. If you look again, you'll see this little control set inside of the assembly. The control set is how the conductor would make the engine go faster or slower. That crankshaft is what they would use to increase the throttle or decrease the throttle. Keep looking, you'll see this little lever here, which is attached to that control set and actually goes into the engine assembly and pushes the throttle open or closed. An example of the use of sheet metal design can be seen in the bottom left corner. As you can see, this part is very thin and just is made of bent sheet metal. If you keep looking, you'll see the unfolded view of the sheet metal, which is just the sheet metal and no bends or folds, so just what the raw piece of material would look like before anyone bends it into the proper positions. You'll also see again those holes, especially the holes on the curvature. Holes on curvature have to be done through a special tool, which makes it very difficult to do edits to those holes, so you have to get those holes exactly precise on the first try. The other assembly I worked on was subassembly SA05-101. This was a fairly simple subassembly as it only consisted of a few pieces. This sheet metal water tank here, a few brackets, this lid for where the water goes in, and the water pipe system which is underneath it, which I will show you in a second. If you look in the bottom right corner, you'll see the 3D model of subassembly SA05-101. As I mentioned earlier, it only has 3 parts. You can see that they're all made of brass. On the bottom, there's a bracket and the feed system for the water. That's what that little pipe shape is down there. If you look closely, there is a hole that goes all the way through it that attaches to a hose, which puts the water through the engine. If you look in the bottom left of the screen, you'll see another sheet metal part. This is the water tank. If you keep looking, you'll see the unfolded view. That little hole in the bottom is where the water escapes into the engine. If you keep looking, you'll see the 2 little notches on either side there. That's where the 2 holes line up in the folded view to make the little holder for the lid. So you would take that lid off and pour water through that hole to fill the tank. As far as team dynamics goes, Leo, made all the SA04 and SA05 parts and assemblies. I also finalized the complete assembly renderings and the full light and quality settings. DT made all the SA02 parts and worked on the SA02 and SA01 combined assemblies. Gabe made all the SA01 parts and assemblies and also worked on the SA01, SA02 combined assemblies. Andrew made all the SA03 parts and assemblies and completed the full assembly.